Okay, we're starting from the beginning. We passed 9-1. We'll come back to you. Hold on. So we are on 9-2. We're on number 6. They wanted to go through number 6. Number 6 is like number 5 because you have to do confidence interval style. So I wrote down the 2 formulas that you need, and the first one is the formula for error, and then the second one is the formula for confidence interval. So like we have to subtract the error, we have to add the error, and do all that stuff, right? Okay. So this is where we're at now. So things that we need from this list, like recent is going to be my number 1 and past is going to be my number 2 because that's the order that they're in, right? So when I'm talking about like mu1, we're talking about recent, and we're talking about mu2, we're talking about past, right? Okay, so things that I need out of this list, like if I say like N1, what does N1 even mean? That's the recent. That's going to be the number of numbers in that list, right? How many? What is that? 17. So N1 is 17. What's N2? Less than that. 12? Okay, so N1, N2. There's 17 and 12. All right, now we need the mean, which is going to be X bar 1. So what's the average in that list? 78.5. And X bar 2? Okay, so we are comparing these two numbers, right? 78.5 and 87.67. Do you think that those two numbers are the same? Or close enough to being the same?
No.
I don't think so. I don't think so. They're pretty different from each other, right? Then we need, I'll put this in a different color. I need S1, which is standard deviation, and I need S2.
13.89.
Ooh, 13.89. I'm running out of room. 13, I'll make that bigger. S1 is 13.89, and S2 is, what'd you get?
7.51.
7.51. Okay, there you go.
Can I ask
So,
a question?
1389, 751. What?
Okay, so when we do this, when we get our answer, then do we compare it back to our claim? Is that what we're going to do?
Yes.
Okay.
Yeah. Okay, so we've got that going on. Those are the numbers that we need in order to be able to do this error formula thing, okay? Now, I also need to know what T is, but I need to fill in my bell curve in order to figure out what T is. So, it says, does it appear that the mean time interval has changed? When it says has changed, does that mean greater than, less than, or not equal to?
Not equal to.
Not equal to, right? It doesn't say one way or the other, so we're going to say equal to and not equal to, okay? And which one is the claim?
The equal to? Or
Sure, let's say the claim is the equal to one. That was kind of weird wording. Has changed. Does it appear that the mean time interval has changed? I don't know. We're going to say the claim is that they are equal, okay? All right, so I have 2 tails, right? And my confidence level, they want me to test 2 different ones. They want me to test 5% and then want me to test 1%. So let's do the 5% first, right? So if let's just do 5%. I don't want to do the 1% right now. We'll get to that when we do the John Baylor thing. Okay, we'll test different confidence levels, but let's do, yeah.
No.
So we got 5%, and since I have 2 tails, we're going to do 2.5% here, and we're going to do 2.5% here, right? Which means I have 95% in the middle. Now, I need to look up on the which chart? The T chart, because N is less than 30. And which degrees of freedom do you go off of?
The 12.
You go off the 12, so degrees of freedom would be 11. So I want to look up 11 on the T chart and 95%. Okay, the T chart is the one with the like 3 bell curves on the side, you know, like you got one of these and then you got a bell curve, you got a bell curve, you got a bell curve. 2.201. Okay, that's what the T is. All right, I use that for this formula right here. 2.201. And then I do the square root of S1, which is 13.89, that guy squared, over N1, which is 17, plus, there's so many things, 7.51 squared over 12. And I get that, and that is the error. The error.
I haven't done that yet, so.
I'm sorry. You can come sit right here if you want to, on the floor.
Crisscross applesauce.
You can sit crisscross applesauce right here on the floor if you want.
One person in the class would do that, which is yeah, and she's not even in here, is she?
I would do that if I was a student, but hey, whatever. Somebody get an error?
I'm working on it.
You gonna take a stab at it?
One now.
8.82.
Woo,
I was gonna say 8.2.
8.82?
See it up there?
You think 8.82 sounds good?
Someone else should try that.
Okay, Matthew got 8.82. Cool. All right, now to figure out, we got to do our confidence interval. So we got to see where mu1 minus mu2 lives.
I did not get that.
You did not get it. Let me see it.
So now we need to add and subtract that from what?
Did you do the square root? Yeah, he's underneath the square. Oh. Okay, so x bar 1 minus x bar 2. So x bar 1 is, I don't know, like a big number.
Is it negative? Is it negative?
It will be negative. So 78, like 78.5 minus 87.67, and then minus that 8.82.
So the positive one is negative 0.35. When you add it.
When you add the error, is negative what?
Negative 0.35.
0.35. I know the answer. This is going to be negative, like real big number.
17.99.
Yep. Sounds good. Okay. So you subtract the x bars, and then you subtract the error, you subtract the x bars, and you add the error, right? And this is what our confidence interval looks like. And what are we looking for now?
I don't know. This is what I'm doing.
Mu1 minus mu2, what should he be if they're equal? He should be 0, right? If I subtract the averages and they're equal to each other, they should be 0, right? Does 0 live in between those two? No. Which means, whoop,
Claim is false.
we cross this one off and we circle this one. Now, is that what we assumed to begin with? Didn't we assume that the averages were not going to be the same because 78 is not the same as 87, right? Yeah, that sounds about right. So we reject H naught, and our claim is false, right?
So on the one before, I should do the same thing. 0
Yes.
should live in between it.
Yes.
So 0 does live in between.
Okay, then you would circle then it would be fail to reject H naught. Yeah.
But that's not.
Okay.
That's not what
So does it appear that the mean time interval has changed?
Yes, it's changed.
According to this, yes, the time interval has changed.
For the one above, is the treatment like the N1 and the sham M2 or M2?
Yeah.
What?
Like is treatment 1 and then sham 2?
Yes. Yes. Treatment is 1 and sham is 2. Yeah,
So
I
you
would say.
do the same equation.
Yep, same equations again. Yep. And those numbers are nicer-ish than number
Those
6.
numbers are less than 30, so it's still a
Yes, so it's still
They're
T-chart.
the same because of
And it's, yep. Oh, wait. Have a greater mean reduction.
Yeah, this is where I'm gonna.
So test the claim that those treated with magnets have a greater mean reduction than sham. So mu1 is equal to mu2 and mu1 is greater than mu2, right? And we're claiming this one, right? So the greater than, we got this shaded right here. All 5% goes there. We have like an imaginary 5% here, which means you're looking up 90% at 13 degrees of freedom.
You are.
and they're both 13.
Yes. So 13 degrees of freedom at 90%, that's going to be the T that you plug into like here, to your equation.
Hey, I have a question.
What's up?
Right here. Okay, so I got this, but then I don't know because my claim was it is greater than. So it's not because it lives in between.
No, it is greater than.
No,
So
because some of
0, if these two were equal to each other, then when you subtract them, like mu1 minus mu2, mu1 minus mu2 would be 0 if these two numbers are the same, right? If these two numbers are equal to each other.
That one's.
So we cross this one off and we say that this is true.
So fail to reject the hoe.
Boom. No, we reject the hoe. Oh, wait. No, on this one, since 0 does live in there, then it is
Okay,
circle
well, you
the
just
top.
said
Yeah,
that opposite.
I
Okay.
just said that opposite. And I crossed off the wrong one. There you go.
I need help.
Okay. All right.
Now,
How are we doing?
The front ones, me and
Okay.
Carter did them, and we have completely different answers. So
Okay.
we need you to,
All right.
we need you
Okay.
to tell us who's right.
Okay. The front ones. Which one? 2 or 3?
Well, we have. Look at this.
How about we try 1? Let's do number 2 together because it's grosser numbers, and then we'll see about number 3. Okay. Test the claim. It says construct a confidence interval. We're not doing it confidence interval style, so I don't know if you cross it off, but we're doing critical value style.
These
Okay.
are completely preferred.
Okay, so Test the claim that the contents of cans of diet soda have weights that have a mean that is less than regular soda. So mu1 is what? First of all, equal to mu2, but then mu1 is less than mu2. Okay, so I only have one tail that I'm shading, and what percent goes in there?
1.
1%. And 1% goes over here, so we're looking at 98%, right?
I got negative 2.475.
Okay,
But
now-
you might wanna
But
check
it
that.
should be on
Now, it should be on the which chart?
Z chart.
The Z chart. And the Z chart for 98% is like 2.33? Yeah! Negative 2.33 and positive 2.33. Yeah? Okay?
Wait, why am I
Because
not sure?
N is bigger than 30.
Okay.
Right? So now I need the formula for like this little guy, and it is something like, oh, I remember this. It is like Z equals X bar 1 minus X bar 2 minus mu 1 minus mu 2. And what do you say about mu 1 minus mu 2?
0.
This is going to end up being 0 no matter what, right? Okay. And then we have the square root is a big old fat square root. And it's S1 squared. I'll just do this. S1 squared over N1 plus S2 squared over N2. Right? So we plop stuff in. Okay. Holy moly. 0.79498 minus 0.81223. The square root of, these are big old fat numbers, 0.00432 squared over 36 plus 0.00747 squared over 36. This is what you need to plug in.
Right.
What? Yes, I pause.
Okay.
Yes, ma'am.
So those ends are the same, but if it's different, then what Z do you use?
The lower one.
The degrees of freedom, you use the lower one.
So
Because you never want to assume more accuracy than you have.
So on the other side we used the 12
Yes.
instead of the 17?
Yes, correct. So you use 11 on the chart. Yes. Yep, good question. Now this one, you didn't need degrees of freedom anyway, but, right.
Can you do this?
So when we type all that in, what do we get?
Well, I can tell you I got negative 11.99.
Woo! What two numbers are we comparing? I don't know. I feel like these two guys are pretty close to the same. Hold on. Let's theoretically look at this, right? X bar, we're trying to compare the X bars, right? 0.79 and 0.81. Do you think those are close enough to each other?
Pretty dang close.
Now, given the fact that the standard deviation is that. So it's not deviating by a whole lot, right? Your standard deviation, because your standard deviation is so low, then that means 0.79 and 0.81 are kind of a big deal, right? Because your standard deviation is so low, 0.81 and 0.79 might be further apart than you think they are. Does that make sense at all? Yeah? Okay, so let's figure out what do you get when you plug all this stuff in for your critical number. Ellie got negative 11 something. I know it's going to be negative. Yeah, 11.99. Cool. Okay. So that means he is all the way over here, which means which one do we cross off?
The top one.
The top one. And we circle the bottom one, which means it is less than, right?
Reject the whole
So we do have diet soda weighing less than regular soda, right? Is what essentially we have going on here. To test the claim, so the claim goes with the bottom one. We are saying reject H naught,
Your claim is true.
and the claim is true.
So I have another question.
Yes, ma'am.
On the other side for 5,
Uh-huh.
no matter if it's like equal to, not equal to, whatever, is the
Yes, correct.
So,
Because you always make a decision based off of whether you're going to cross this one off or circle this one.
so
And so 0, if 0 lives there, you're going to circle this one. If 0 doesn't live in the middle, you're going to cross this one off. Does that make sense?
0 does live in the
So then you're going to circle the top one and cross off the bottom one. You always make your decision based on H naught, right? Like either we reject H naught or fail to reject H naught. The whole decision is based off of the top one. Okay. Boop, boop. Okay.
Okay, has anyone done number 3?
Are you on 9-3?
This is no. This is 9-2.
Okay.
This is number 2. This is the front side. We just
Have
got
you
into
done
it.
number 3?
Stop.
Okay.
Oh, wait, he's ripping holes in my paper.
Pinch me.
After he ripped a hole in my paper.
Well, this one actually, I like how they put them in
3.
I'm gonna start charts, then I'm gonna start two, so I don't have to write
You.
them
Yeah. Yeah, that makes it nice.
the
Like
smaller
this.
one,
This
right?
is really handy right here.
Yeah.
Now, do we use the T chart or the Z chart?
T.
The T, because our degrees of freedom is
Less than 30.
27.
Not
Yep,
really.
less than 30. Yep.
Pretty confident in this one.
Okay. Then we got to do to test the claim that the two samples are from populations
Can you
where
tell
the
Aiden,
mean
can
is
you-
the same.
Can you tell us what our.
So we're doing mu1 equals mu2 and
Unless I put it in my calculator.
mu1 is
Are you hitting
not equal. Yep. I heard Mal say it, I think.
What is it? But I
Equal,
need to-
not equal to. So we have two tails, right? And what percent goes in each one?
one at a time.
Like a half of a percent, right? A half of a percent. So we're looking at 99% and 27 degrees of freedom on the T
Yeah, I want
chart.
to know what that is.
Okay.
I want
T chart. They have the
I want
T chart.
someone here.
Really, we literally got the same answer on this.
99% at 27 degrees of freedom. I got 2.771.
Huh! You used the wrong chart. Booyah!
But 28 is less than 30.
Correct. So use the T chart. And you use 27 and 99%. There, 2.771.
Why did I use the other side?
I don't know.
Call me-
Because that's standard deviation.
call me-
That's the
I was
chi-square
right
chart.
Twice. I was right twice.
So now we've got 2.771. Oh wait, we don't even need the 2.771 for the formula. We just need 2.771 lives here and negative 2.771 lives here.
Same answer as the other one.
So I've got mu1 is, no, x bar 1 is 2.37 minus 2.64 on the top over the square root of 0.96 squared over 28 plus 0.61 squared over 38. And I need to know that number.
It's negative 1.31.
Negative 1.31 is what Ellie says that it is. And where does he live? Pretty much right in the middle, like over here, right? Oop. He lives right here. Which means what? Circle the top. They're equal. So, to test the claim that the two samples are from populations with the same mean, does that mean my claim goes with the top or the bottom?
Claim is the top.
Claim is the top. So, FTR, H naught, claim is?
True.
There you go.
Bam.
As long as that's right, is that correct that it's negative 1.31?
That's what part I got.
Okay. Cool, cool. How about that? The top one's the claim. You betcha. That's 3, 4, and 6. Now you only got 5 by yourself. How are we feeling? Okay, who has done, just by a show of hands, who has done 9-3 something or other?
Just watch the
I
video.
think I left a video for it.
I watched the video. That's about it.
Can you go back?
Okay. Okay.
Here's this.
Okay. I'm going back to number 3. There he is.
Can you scroll up?
No. But we only have to do odds for homework. We have 3 problems, but I didn't do any of them.
On 9-3?
I
Okay.
didn't do the homework.
Alright, don't do the homework yet. Because I might replace it with the John Baylor thing. No, you're not watching John Baylor at all. You're analyzing data from John Baylor.
Okay, that's better. I don't want
That's better?
ever again.
Okay. He doesn't even do the John Baylor stuff anymore.
Yeah.
It's some lady that does it.
Is it one of his kids or something? Or
I don't know. I don't know.
So this is
So, 9-1, 9-2. Make sure I have those from you. If you want to pass those like 9-2s in right now and you're done,
9-1.
that would be great. Okay, 9-3. So now I have a game plan, all right? 9-3. I'm gonna go through some formulas and notes and stuff on 9-3. For those of you who haven't watched it, I'm gonna do that tomorrow. We're gonna do some John Baylor stuff on Friday. That's the end of this week, and then next week we start our final project, our final packet.
So we don't have like a final test.
No, it's your final packet.
So this is our final.
This is your tomorrow's like your final section that you'll learn. 9-3 is it.
We didn't have
Yes. Yes. Okay. All right. So I'm gonna stop this video. We did all of them on 9-2 except for number 5, and I did some of that already. So there you go. Okay. What?